In this video, we're going to use Pythagoras to feel our way around this similar triangle's proportionality. And so they've given us that PR is 16 and ST is the perpendicular bisector. And so before even writing 16 for PR, I'm rather just going to simply write 8 and 8. And QR, the whole length here is 14 centimeters. Okay, what's buzzing through my brain immediately is that I could just do a Pythagoras with the big triangle. The other thing is I've got the 90 degrees, but I've got no other angle. And so one thing that you can do is let something be x. For example, if you made rx, then this would be 90 minus x. In the big triangle, if you've got a 90 and an x, p would be 90 minus x. And you could work out the other side here. This would just be 90 plus x. If this is 90 minus x, angles on straight line. So I won't need that for this question, but it's just helpful to know. In geometry, you can get questions where you just feel like there's not much information. How do I start? And the best thing is just to let something be x and work your way around from there. So to prove that these two triangles RQP, the big one, and RTS, the little one, are similar, the first thing that I notice is that they both have a 90 degree. So angle Q equals angle STR. How did I know that? It was given. And the other thing I notice is they both share angle R. Helps to notice that that's the first letter of both triangles. So angle R is common. And then you only need two angles to prove similarity, but for good measure, the remaining angle, so angle P, which it's helpful visually to see that it's 90 minus x, and so my eye is drawn to the other 90 minus x, TSR, those are equal, and it would always just be sum of triangle if you're needing. Therefore, these two are similar. Reason, angle, angle, angle. At this point, as a habit, if you've seen any of my other videos, I find it helpful to take the similar triangles, even if you couldn't prove them, and immediately just write the ratio of fractions. And so the first two over the first two, the first and last over the first and last, and the last two letters over the last two letters. How do we know that? Because we've just proved that the triangles are similar triangles. Now they want the length of TS, which I notice is down here. And so I'm going to choose one of these other ratios to work in conjunction with this ratio. I'm just going to see which I have measurements for. So RQ, I've got 14. RT, I've got 8. Okay, so I'm going to use this one as well. And when I rewrite it to do the question, because I want TS, I prefer to make my life easier and less stressful in the middle of an exam. And so I'm going to put the TS on the top. So I'm just going to flip both fractions from what I'd written and circled. So both fractions just flip around, which is totally legit. And now I can start filling in what I have. So RT is 8, RQ is 14, TS I'm not sure at the moment, and QP I'm not sure at the moment. But I know that QP, right back to my first statement that I can see a Pythagoras happening, I can just work that out quickly on the side here. So QP squared is the hypotenuse squared minus the other side squared, and that gives you 60. So QP is the square root of 60, and the rest should kind of be easy from here. So it's 8 over 14. The QP at the bottom will go to the top. I call that escalators. Something that's on the bottom ends up at the top. And if you punch that in your calculator, you get your answer of 4.26. And that is a helpful way to work this out. Let me just change this quickly. 4.43. I hope you found this video helpful. If you did, please like it, subscribe to our channel, and share it with your friends.